Hello everybody, my name is Sigflop Sinislabel, also known as Assembly, and in this YouTube video we're going to be exploring Daytrip's source code, which I'm not releasing because it's really ugly. So we have our main directory here with some things. And the first thing we have is a Z80 folder, which contains the Z80 program. This is the Z80 program. All it does is it gets a character, and then if that character happens to be over this address, it does a bank switch. So it gets contiguous bytes. With those contiguous bytes, it stores them as an opcode with operators, and the opcode is switched in a switch statement with different VGM commands. This is a modified VGM file where you have two ops, guaranteed per instruction, VGM instruction. If you're familiar with those, you have one op or two, but this is guaranteed to have two ops. So I do a bit of pre-processing on the VGM file. That's to make it symmetrical and since the Z80 has no timing or anything like that, it's good to have symmetrical code. Code that runs in the same amount of cycles per iteration. So that's that. There's a special address here called VGM pause. That's our timing address, which happens to be at 50 in the Z80 memory. So this is main. Not all that pretty. This is where we set up the vertical and horizontal hooks to no routine. We set up all the registers and install the Z80 program right there. We also change the brightness and fade to, and a few other variables. And then we turn on the screen, flip on the screen right there, and go into our loop. Our loop does a vertical sync, updates the palette, sees if we are the first tick of a scene. If we're the first tick of the scene, we call its init routine. Then we have update VGM pause, which looks very pretty. Which is right here. As you can see, we get the Z80 bus. Write the VGM position into 68K memory, and then drop the Z80 bus. This is, I said that we call init function if it is the first iteration of a scene. This is our scene file right here, which contains all the references that we call. First we init a scene, and then we take a scene, and this is the order of the scene. This is the VGM pause at which the scene ends, which is hand-coded right there. No timing interface or anything like that, like just by watching and hand-coding it. So let's look at a scene. Let's look at test 2. Right, test 2 is, I believe, let's not look at test 2. What scene should we look at here? I have to see what the scene progression is. There's one that I want to look at, but I forget what it's called. Prescription, vector balls, waiting room. Where's waiting room? I'm looking for the waiting room in Dr. Vertical. There it is, called Vertical. This is the waiting room scene where you have a vertical sort of cool looking thing. What we do is we init, we make the background right here. That's making the background. We set up a vertical scroll to be every 2 cells and set the horizontal counter to 2. And this is working off a table in which we scroll vertically based on what is in the table. This is the assembly code to do that. This is run per scan line, and you can see it's run per vertical scroll. This is our very first screen. We initialize it. We set the horizontal scroll to 1, the horizontal interrupt timer, that is, to 1. We write patterns and scroll data, set up the background, and move sprites. This happens to be the registering of a new sprite. And this is the story with the clock positions, the character, and then the destination the destination coordinates, which is another hand-coded thing. What else can we look at? I called the Twister spiral for whatever. This is the message storage right there. What you need is a steady diet of twisters. This is the horizontal hook, in which we we move VSRAM to a particular location, and based on the horizontal position plus the looper, which is pretty cool. That's where the twisting comes from. Pretty standard in it. Write patterns, write the font, write scroll data, clear some things. I really should be doing DMA clears for these, I realize, but I had a problem with doing DMA fills. And yeah, that's it. I guess that's all I'll share. Thanks for watching, everyone. Take care. Bye-bye.